Okay, 13. Jerry has a new job and earns a salary of $45,000. Okay, so Jerry earns $45,000. Victoria has a new job and earns $54,000. Jerry will receive a salary increase of $2,500 per year, and Victoria will earn a salary increase of $1,500 per year. Which equation can be used to find X, the number of years it will take Jerry to earn the same as Victoria? Okay, so since they're going to earn the same, that's why these two equations are equal to each other, because 1/2 is going to be Jerry, 1/2 is going to be Victoria. So let's see what we know about these two. Okay, Jerry earns $45,000 and Victoria earns $54,000. Jerry is going to get an increase of $2,500 per year, and Victoria is going to get an increase of $1,500 per year. All right, so Jerry is $45,000. Well, over here in my answer choices, all of the ones on the left of this equation have that $45,000. So this side is going to be Jerry, and this side will be Victoria. He's only going to make $45,000 one time, so we are not going to multiply that by anything. And A, B, and D all have us multiplying by X. Well, we're not going to do that. He's just going to get paid that one time. Plus, he's going to get $2,500 per year. This is where our multiplying comes in. So this is why the $2,500 would be multiplied by X. Victoria makes the $5,400. She's only going to make that one time, so it doesn't get multiplied by X, which A, B, and D all have. And then the $1,500 per year, that's where we would multiply. So our answer choice is C, because Jerry gets his $45,000 plus his $2,500 per year is where the multiplying comes in. Victoria gets the $54,000 plus the $1,500 per year, which is where the multiplying comes in. All right, number 14. Yes, this is a lot of reading, okay? Ideally, yes, you would read all of this. But let's see if we can eliminate some things by just scanning. All right, which situation can be represented by this equation, 7x plus 1 equals to 10x? So I am multiplying something by 7, and I'm multiplying something by 10. Okay, so F, here we have 7 miles per hour and 10 miles per hour. So that's our multiplying. So we can't eliminate F just yet. G, we have our 8 points per hour, 10 points per hour. That's not matching up with multiplying by 7, so we can eliminate G. H, I see this 1% here. There's nothing about a percentage up here, so we can eliminate H. J, Brody rode his bicycle on 2 different days. The first day he rode 7 miles per hour, and then we have our 10 miles per hour. So F and J both have us multiplying by 7 and multiplying by 10. All right, so we just quickly eliminated G and H, so that gets rid of a lot of the reading we have to do. So let's go back and read. Brody ran at a constant rate of 7 miles per hour. That's good. That's multiplying by my 7. Candace ran at a constant rate of 10 miles per hour. That's good. That's that part. In a race that started 1 mile in front of the starting point. That's got my 1, so that's good. All right. What is X, the number of hours that Brody and Candace would have to run in order for their distances to be the same? That's got them equal to each other, so that's good. All right, J says Brody rode his bicycle in 2 different ways. The first day he rode 7 miles per hour, so that's got my multiplying by 7, and started 1 mile from his house. There's my plus 1. The second day he started from his house and rode 10 miles per hour. That's got the multiplying by 10. What is X, the number of hours that Brody would have to ride his bike to travel the same distance in both days? So F and J are very, very similar. So let's see if we can figure this out. All right, so Brody ran 7 miles per hour. Candace ran 10 miles per hour. And Candace started 1 mile in front of the starting point. So this would be Brody, and this would be Candace. So she would get the +1 because she's starting 1 mile in front of the starting point. And they're the same, so they would equal each other. So this isn't quite right. All right, so Jay has Brody. And he is 7 miles per hour, and he started 1 mile from the house. And then the second day, oh, sorry, both of these are Brody. So this is day 1, and this is day 2. So the second day, he rode 10 miles per hour. Okay, on day 1, Brody rode 7 miles per hour plus 1 mile from his house. On day 2, he rode 10 miles per hour. They're equal to each other. This one matches my equation, J does. And F was really, really close, but it was not the right answer. Okay, so even though it's a lot of reading, you can kind of limit it down and you can do it. Okay, what is the solution to this equation? We want to solve this equation. It's a griddable. I don't have any answer choices. I'm going to rewrite this so I can have some more room to work. So I have 2x plus 3 is equal to x minus 4. The way you solve an equation is you divide it in half. You can only add common things to each other. So the x's, I can combine with the x's. And the numbers, I can combine with the numbers. So let's get our x to one side. So I have 2 x's and 1 x's. So I want to move this 1x over. So this is a positive x. So I'm going to subtract x from both sides. When there's not a number in front of it, we just know that's 1x. But if it makes you happy, you can put the number in front of it. So 2 minus 1 gives me x. And then this subtracted away. I still have plus 3. And I still have minus 4 or negative 4. So x is on this side. I want to get my numbers to the other side. So this is a plus 3. I want to subtract 3 from both sides. What I do to one side, I have to do to the other side. So this subtracts away. X is going to equal to negative 4 plus a negative 3 is going to be a negative 7. All right. Since this is a griddable and I don't have any answer choices, I want to double check myself. So I'm saying the answer is negative 7. A way I can double check myself is I can go back to the equation. 2x plus 3 equal to x minus 4. I'm saying x can be replaced with negative 7. So instead of x, I can say it's negative 7. So if this is correct, both sides of the equation will equal. So 2 times a negative 7 is a negative 14. Negative 7 minus 4 is a negative 11. And if you aren't good with your integer rules, you can always use your calculator. And negative 14 plus 3 is negative 11. So both sides of my equation balance. So this is the correct answer that I'm going to want to grid in. All right, another way you can do this is you can use your calculator. And you would divide your equation in half. And you would put 1/2 in y equal. And you would put the other half in y equal. So you would go to y equal and put in 2x plus 3 in y equal, and go down and put in x minus 4. All right, and then you can use your table. You can go to second and table, and your answer is where your y's have the same number. So we just worked this. I know my answer is negative 7. So when I arrow up to negative 7, see how I get the negative 11s from where we double check the work? Okay, and that balanced. This is the same thing. So I know negative 7 is my answer because those balance on the calculator. So I've double, triple checked everything, and I'm very confident that negative 7 is my answer. Okay, number 16. Julie started with 20 pieces of gum and gave away X pieces. Conrad started with 35 pieces of gum and gave away twice as many pieces as Julie did. How many pieces of gum did Julie give away if they had the same number of pieces of gum left? Okay, one way we can work this is we can set up an equation. Julie has 20 pieces of gum and she gives away 1 piece of gum, so that can be our X. Conrad has 35 pieces of gum. He gives away twice as many, so he'd be giving away. Okay, so Julie has 20 pieces of gum. She's given away 1 piece. Conrad has 35 pieces of gum. He's given away 2 pieces. Divide your equation in half. Combine your x's. So to get rid of minus x, I would add x to both sides. So I'd have 20 is equal to 35. And then negative 2 plus 1 would be a negative x. Okay, we need to get rid of our 35, so I would subtract 35 from both sides. That zeroes out. That gives me a negative 15 is equal to a negative x. Divide away your negative, so that 15 is equal to x. Okay, so I can set up an equation. I can solve an equation. I can use my answer choices and guess and check. If Conrad's given away twice as many pieces, 18 times 2 is 36, and that's more pieces than he started with, so that won't work. If it was 5, I can say Julia gave away 5 pieces. That would give her 15 left. Conrad doubled that. That would give him 25 left, so that doesn't equal. So it wouldn't be 5. Okay, Julia has 20, Conrad has 35. If we say Julia gives away 15 and Conrad gives away twice as many, that would be 30. And Julia would have 5 left and Conrad would have 5 left, which is just like the equation we solved, saying that she gives away 5. If we did it with the 8, answer choice J, if she had 20 and he had 35 and she gave away 8, she'd have 12 left. And if he gave away double 8, he would have 19 left, and that doesn't equal. So the only one where she can give away 15 and he can give away 30, that's going to be H, and that leaves them both having 5 left over.